how to use the sine rule and cosine rule in trigonometry, you are not going to do well for math. And I do not want that. So in this video, I'm going to teach you exactly what sine rule and cosine rule is and how you can use it to answer questions that ask you to find unknown sides or unknown angles within a triangle. Not necessarily it has to be a right angle triangle, but certainly, any triangles, anything with 3 sides and that has 3 angles in it. So right off the bat, let's just talk about sine rule and cosine rule. What is it? So first and foremost, sine rule, cosine rule. Consider this triangle over here. This is angle A, this is angle B, this is angle C. This is side A, this is side B, this is side C. Now, sine rule states that for a triangle, sine A over A equals to sine B over B equals to sine C over C. Likewise, this also translates to the fact that A over sine A equals to B over sine B equals to C over sine C. Now, on the other hand, cosine rule states that cosine, let's say given the angle cosine A is just B square plus C square minus 2A over minus A square over 2BC. Now note that the capital letters refer to the length of the sides, whereas the small alphabets refer to the angle, right? Be it in degrees or radians, these small alphabets refer to the angle. And likewise, from here, the side A square equals to B square plus C square minus 2BC cosine A. So this is how the formulas for sine rule and cosine rule work. And now, when do we use this, or why do we learn sine and cosine rule? And that's very simple. It's simply because sometimes in the question they may give us, two known sides and one angle, and they will ask us to find the remaining side. So consider this triangle over here. They give you this angle. This is angle A, this is side A, and we don't know the length of this, but we know the length of B and we know the length of C. So given that we know the length of B and the length of C and the angle in between, which is A, we can use the cosine rule to find length A. And in this case, A will be the unknown, so A square will equal to B square, which is what we know over here, plus C square, which is what we know over here, minus 2BC, which is, the values of these two, cosine A, given that we know what this is. On the other hand, for sine rule, okay, so over here would be for cosine rule. For sine rule, it's more of we are given. Why do we learn sine rule? This is when we are given two known sides and one non-included angle. So in this case, the angle is included for cosine rule because the angle over here is in between the two known sides that we are given. That's why we call it the included angle. But in this case, it's non-included. So consider this triangle over here, right? This is side B, this is side A, and we are given this angle over here, A, right? So we are given two known sides and one non-included angle, which is angle A. And we are asked, how do you find what is angle B? So using the sine rule, we have A over sine A equals to B over sine B. And we know the values of this, and this because the question has already given them to us. And therefore we can just plug the values of A inside here, A, the small angle A inside here, and B inside here, and we will be able to find what this B is. By just manipulating the equation, we can get this, right? We will be able to get sine B equals to B divided by A over sine A. And B would just be sine inverse B divided by A over sine A. And this is how we find the angle of B. So in summary, we will use sine rule when we are given two known sides and one non-included angle, such as this example over here, to either find the unknown angle or the unknown side, which is C over here. Right? We can use sine rule to find unknown sides, unknown angles. And we'll use cosine rule when we are given two known sides and one included angle to either find this unknown side or unknown angles over here. So with enough practice, you will be able to know how to apply each rule into the question and quickly spot, right? Math is all about practice. So the more times you practice, the quicker you will be able to spot what kind of rules to use in either case. And let me just give you an example right now. So consider this question. This is question 1 out of 3 questions that we will be going through in this video. Now, in a triangle ABC, AC is 5 cm, BC is 7 cm, and angle ABC is 40 degrees. So consider this triangle over here. Okay, so we have this triangle over here. This is A, this is B, this is C. Right? And AC is 5 cm, BC is 7 cm. And we don't know what is this side over here. And this angle over here is 40 degrees. And we don't know what this angle is, and we don't know what this angle is. And we want to find what is angle BAC. So this is what we're trying to find. So now that we look at this question, we are given two sides as well as one non-included angle. And therefore, we will use the sine rule. Now, that means sine 40 degrees over the opposite side. So it will be 5. 5 equals to sine angle BAC, which is what we are trying to find over here. And we will take the opposite side, which is 7. So it will be over 7. And therefore, we can manipulate this equation over here to get sine angle BAC is 7 sine 40 degrees over 5. And therefore, angle BAC is just sine inverse 7 sine 40 degrees over 5. And you will realize that there are two possible values that come out of this, right? Angle BAC is either 64.145 degrees, or angle BAC equals to 180 degrees minus 64.145 degrees. And that will give you either 64.1 degrees or 115.9 degrees to 1 dp. And you will then continue on with the question to determine whether it is this acute angle or whether it's this obtuse angle. But either ways, this point of the question, you will take either values over here, because either values make sense. And why do we have two different values? Because it goes back to this concept that I've taught in my earlier video, which is the sine, cosine, tangent of acute, obtuse, reflex angles. Basically, in math, we have 4 quadrants, right? This is so consider this Cartesian plane. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Inside this quadrant, for whatever angle that exists inside here, that means for quadrant 1, it will be from 0 degrees all the way until 90 degrees. Anything below 90 degrees from 0 degrees. Over here, all sine, cosine, tangent will be positive. So that's why we will denote this as A. A meaning all positive. Inside over here, all the angles, for all angles, only sine is positive. That means for cosine and tangent, it will be negative inside quadrant 2. And we'll denote this as S because only sine is positive here. And using this pattern, only tangent will be positive in the 3rd quadrant and only cosine will be positive in the 4th quadrant. And since angle BAC or sine angle BAC over here, this is positive, that means angle BAC can exist either in the 1st quadrant or in the 2nd quadrant because the sine of angle BAC is positive, and therefore it's either in quadrant 1 or quadrant 2. And therefore this is the angle of which it will be in quadrant 1, and this is the angle which it will exist in quadrant 2. And that is why we have 2 different possible values of BAC. And if you actually plug these values over here, 64.1 and 115.9, back into sine angle BAC, you will be able to get this value as well. You can go ahead and check your answer if you do not believe me. Okay, so that is for question 1. For question 2, now consider this triangle. In a triangle ABC, BC is 4 cm, AC is 3 cm, angle ACB is 115 degrees. So we have this triangle over here, right? And this is C, this is 4, this is 3, this is B, this is C, this is A. And let's assume this is 115 degrees. All right, this is 115 degrees. I'm saying that this 115 degrees. Now, we want to find what is this length AB. So what are we given in the question? We are given this side, we are given this side, and we are given one included angle. And therefore, we will use cosine rule. So by the cosine rule, c square in this case equals to 4 square plus 3 square minus 2, 4, 3 cosine 115 degrees. And therefore, you just key this into your calculator, you'll get c square is 35.143 ... And therefore c is just square root plus minus square root of 35.143 ... You get 5.9281 ... or equals to negative 5.9281 ... And we will reject this as c is positive. And why is c positive? Because c is a length over here and we can't have a negative length. So we will only take the positive value of c, and therefore c is 5.93 cm to 3 SF. So this is how to use cosine rule to find the unknown side. And now for the last question over here, question 3, using this extension, now let's find unknown angles using cosine rule. So consider this triangle over here, ABC, where AB is 6 and BC is 7 and CA is 4. What is angle ACB? And this is how the triangle looks like. You have B, you have A, you have C. 6, 4, 7. What is this angle over here? Now we have 3 known sides and one unknown angle. So this we will use cosine rule. So just as an extension over here, plus 3 known sides. So when you have 3 known sides, you can find one unknown angle. And how do we do that? This angle over here will be, let's name this angle C. Alright, so cosine C is just 7 square plus 4 square minus 6 square. Right, so if we were to name these conventions, this will be side C, then this will be A, and then this will be B. And as we all know, cosine C is A square plus B square minus C square over 2AB. So it will be as such, 2AB. And C is just the cosine inverse of this value over here. And you will get 58.811 degrees. And therefore, it is 58.8 degrees to 1 dp. And yep, so this is how you use cosine rule to find unknown angles, unknown sides, and you can use sine rule to find unknown angles and unknown sides as well. And I hope this video has been helpful. If you like to get more resources and get more help from me, go ahead and check out the link in my description. If not, I wish you all the best for your math journey ahead. Remember to subscribe, and I'll see you in the next video.